All right, we're going to get to the second part of 4-4. We're on page 250 in your textbook. And so we're still dealing with complex numbers, and you learned about imaginary units. All right, so we're going to see kind of how some of these work. They work the way you think that they would, I would imagine, if you thought about it. But we've got to do some things. So I'm at example 4. And this is a little bit weird one. I'm not going to give you much of these, but I do want to show you how to set this up. Okay, so we're going to find the values of x and y that make this statement true. And the statement is 3x minus 5 plus y minus 3 times I. Remember, that's our imaginary unit, equals 7 plus 6i, and we want to know what values for x and y make this true. It looks tough, but it's not tough at all. So you're going to split this up into 2 problems. You're going to take the stuff with the x's and the plain number and put it together. Then you're going to take the stuff with the i's and put it together. Okay, so here's what it's going to look like. It's going to be 3x minus 5. Okay, that's not with the I. It's on this side of the equal sign. It's kind of by itself if you're thinking of it that way. And I'm going to set it equal to 7 because that's not with an I. All right, then I'm going to set the stuff with an I equal to each other. So y minus 3 equals 6. So I'm not putting the i's in, but I've got the stuff that wasn't with the I, or with either I equal to each other, and the stuff that was with the I equal to each other. And without the I, that's all you got to do. And then you just solve. So over here we'll add 5 to both sides, get 3x equals 12, divide by 3, x equals 4. Pretty simple. Over here, even easier. Add 3 to both sides, y equals 9. And there's your 2. Real quick, that's not hard. We're not going to do a ton of that. But that's helping make a statement true that's got complex units in it. Okay, pretty simple to do. I can help you on that as you see it. All right, let's go down and look at simplifying complex numbers. So we're at example 5 now, part A. Okay, and it says this. It says 5 minus 7i plus 2 plus 4i. Okay, they're going to write your imaginary factors in parentheses, which is fine. When you do the math, it's really, really simple. Okay, I first thing like to just go drop the parentheses so I can look at all of it. Since this is a plus sign, none of the signs change, and now it's just a like terms thing. The only thing is you put your constant first and your I term second. So my like terms are 5 plus 2, which is 7. Then I have minus 7i plus 4i is minus 3i, and that's your complex factor right there. Really, really simple to do, okay? 5b with a subtraction in there, all right? Still pretty easy. So we got this 4 minus 8i minus 3 minus 6i, okay? Now that negative sign needs to be distributed, so I'm going to change these 2 signs. So this front one is 4 minus 8i, and then minus 3 plus 6i. So again, that's the opposite of 3 and the opposite of negative 6i is how we get that and do like terms. 4 minus 3 is 1. Negative 8i plus 6i is negative 2i, and there's your complex root right there, okay? So just getting used to that, not hard, pretty simple stuff to do. Let's start getting into some stuff that can be, maybe be a little bit tougher, not too bad. I'm going to go ahead and flip the page so I got room to work. We're on page 251, jumping all the way to example 7. All right, I got to show you a couple of these and what to do when you start seeing i's in a fraction or something like that. All right, so I got this. I got 2i divided by 3 plus 6i. Okay, so we got to go get rid of the i's. This is example 7, and this is part A. So I got to get rid of the i's. So here's how we do it. We multiply this thing, or by this thing called a conjugate. All right, and conjugates work 2 ways. For us, here's how it's going to work in this one. I'm going to multiply this, all right, by the conjugate. The conjugate is going to be the opposite sign of whatever your I term is. So in this one, it's going to be 3. The 3 stays the same, but my plus changes to a minus. And I'm going to multiply by 3 minus 6i. And if I do it on the bottom, I'm also going to do it on the top. So let me introduce you. This right here, it looks tricky, but all that's happening is I am multiplying this problem by a special form of 1. 3 minus 6i divided by 3 minus 6i is the equivalent of the number 1. If you multiply a problem by 1, you don't change it. So this is how we're going to do it. Now we got some math to do, okay? In the numerator, I've got 2i times 3 minus 6i. Let me remind you, you wonder what I'm doing. We multiply fractions straight across. This is called a complex conjugate, okay? On the bottom, I've got 3 plus 6i times 3 minus 6i, okay? So that's the math that now needs to be done. All right, so simply however you want to do it, on the top, I'm distributing 2i, so 2i times 3 is 6i, and 2i times negative 6i is negative 12i squared, we'll deal with the I squared in just a second. You may remember that from the last lesson. All right, on the bottom, we got a FOIL. So I do first terms. 3 times 3 is 9. I do outer terms. 3 times negative 6i, negative 18i. I do inner terms. 6i times 3, positive 18i. And I do last terms. 6i times negative 6i is negative 36i squared. Sorry, I didn't leave myself a ton of room right there. Again, this bottom reads 9 minus 18i plus 18i minus 36i squared. So at the beginning of this problem, I didn't tell you what we're doing. The reason we're simplifying this is we can't have an imaginary unit in the denominator in a final answer, okay? The reason that complex conjugates work is because your middle term is going to cancel out when you flip the sign. So here's kind of what's left, and let's look at it. It doesn't look clean, but it's going to be pretty simple to clean up. So my numerator is 6i minus 12i squared. My denominator, since my middle term canceled out, is 9 minus 36i squared. You're like, well, I didn't clean it up. Yeah, I did. Remember, I squared goes to negative 1 or is the equivalent of negative 1. I'm just going to sub that in. So I'm going to write this out here. I won't do this much anymore, but I've got 6i minus 12 times negative 1. And on the bottom, I've got 9 minus 36 times negative 1. So we can plug those values in. There's still going to be an I in the numerator. That's fine. There's no issues there. Okay? So this cleans up even more. 6i, now negative 12 times negative 1 is positive 12. Then I've got 9 on the bottom plus 36. Well, we can do that math, right? So the whole bottom, when you multiply by that complex conjugate, turns into a number. That's why we do this. So let's keep going. So the top, 6i plus 12 over, now 9 plus 36 is 45. So what we've got going on here then is we've got this fraction, all right, 12 over 45, and I've got this 6i over 45. Now, and this is a good lesson to learn, when you reduce these, here's what's really happening. I've got 6i over 45 plus 12 over 45. Now, you don't have to write that step, but mathematically, that's what's happening. Now, if you're not good at simplifying those, and let's go do it. Now, I'm going to do the number first because the number is going to go before the I term, or your imaginary unit, okay? So I'm going to do 12 divided by 45. Math, enter. Look what we got, 4 over 15. So I'm going to kind of flip how I'm writing this. I'm going to put the number in front, so that's 4 over 15. Now, I'm not going to do 6i divided by 45 because that I is going to stay there. I can just do 6 divided by 45, math, enter. I get 2 over 15. So this turns into plus, 2 over 15, and then just write your I out beside it, okay? I messed up that 2 right there. So 4 over 15 plus 2 over 15i. We just move that I out to the side. Another way this could be written, all right, is like this. It could be written 4 plus 2i over 15, where it's over the same denominator. That just happened because it reduced the same. Either one is right, okay? So that's what happens when you have a 2-term imaginary in the denominator. All right, let's go to 7b. All right, and let's look at this one. Now, this one is 4 plus I. It's 2-term on the top, but only 1 term on the bottom. So the way that your complex conjugate works, you don't have to change the sign with this. You're not going to come multiply by negative 5i. You only do what we did there when it's 2 terms in the denominator. It's only 1 term in the denominator, so I'm just going to multiply by I divided by I. That's the step when it's only 1 term with an imaginary in the denominator. All right, so here's what ends up happening. So on the top, and I'm going to rewrite this, I've got I times 4 plus I, just kind of move the order around. And on the bottom, remember again, we're just multiplying straight across. Sorry, I didn't roll my arrows. On the bottom, I've got 5i times I, which is 5i squared. Hopefully we can get that. I times I is I squared. All right, let's keep going. I times 4 is 4i. I times I is, I've got a positive, but remember, that ends up being negative 1. So that's going to turn into minus 1. If you see that, go ahead and change that. Okay? Now the bottom turns into 5 times negative 1. Because remember, I squared is negative 1. All right, so let's keep going. The top, 4i minus 1. All right, divided by negative 5. All right? I need to flip some order here. Now, if you do what we did in the last problem, I'm going to split this fraction up. So that's negative 1 over negative 5, which is 1/5. Okay? Now, 4i over negative 5 is going to be negative, and I'm going to put my 4/5 there, and I'm going to move the I out to the side. You can leave it in the numerator. Your book's going to pull it out to the side, so we can pull it out to the side. That is our answer. It can be written that way, or at this step, you need to flip this stuff around. So what would happen, this -5 in the denominator would cause all my signs to flip, and I'd be at 1 minus 4i over 5. You could write it that way as well. Okay, just kind of make notes. Can look 2 different ways, and just pay attention to what it's asking for. All right, complex numbers, a little bit tricky as it seems, but it's really not hard. We're trying to get things to I squared so we can turn that I squared into -1. As always, if you have questions, get up, come see me. Let's get it figured out. Thanks.